Hello, Rockbridge Pre-Calculus. It's time again for pre-calculus. Okay, we're going to talk about rational equations and partial fractions. In math, rational means can be made into a ratio. So a rational equation consists of one or more rational expressions, that is, expressions with a variable in the denominator. One way to solve them that we're going to use is to multiply each side by the least common denominator. Any possible solution that results in a 0 in the denominator must be excluded. That is, since you're dividing, you've got to check for division by 0. Sometimes you will need to factor, and sometimes you can do the sum of partial fractions. We'll get to that. Example 1. So to solve this, there's variables in the denominator. We need to, essentially, our goal is to get the variables out of the denominator so we can solve it in a more straightforward manner. And so just like you would when you were adding or subtracting fractions, you must get the least common denominator. We have 3 times x minus 2, we have 6, and we have x minus 2. Our least common denominator has to have 3 as a factor. It has to have x minus 2 as a factor. It has to have 6 as a factor, but 6 already contains a 3, so if we just make that 6, that'll work, and it has to include x minus 2 as a factor. So here's our least common denominator, 6 times x minus 2. If you need a review in finding least common denominators, please go online and look for one. This is not something I'm going to spend any time on in class. So we need to multiply everything by this, and if we've done that correctly, all of our denominators will cancel out. So multiplying by 6 times x minus 2 over here, x minus 2 and x on the top and x minus 2 on the bottom cancel out. 6 and 3 reduces to 2 over 1. So the left-hand side becomes 2 times x plus 1. On the left-hand side, here, the 6 cancels out, and so you'd have 5x times x minus 2, which is right there. And for this one, the x minus 2 cancels out, and the 6 stays. So this turns into 6 plus 1. Then it's just a matter of figuring out what kind of problem you've got and how to best solve it. After you've simplified everything, you'll find that it's a quadratic. The best way to solve a quadratic is to get everything on the same side. 5x squared minus 12x plus 4. Quite often you can solve it by factoring, graphing, or quadratic formula, or completing the square if you like. But this comes out to be x equals 2/5 and x equals 2. Remember that anytime you have rationals, you've got to check for division by 0. So, apologize. What would cause the denominator to be equal to 0? Well, 2, so x cannot be 2. You can't make 6 into 0, that's fine. And x minus 2, we've already covered. So x cannot be 2, so we get rid of that, we exclude it. And so the only solution is 2 over 5. I'm going to cover decomposition into partial fractions in a separate video, so you can look for that. I'm going to move on right now to example 3, solving inequalities. You do this much the same way, but since you're going to end up doing multiplication and division, that's just the way we solve those. If your variable is negative, that would mean multiplying or dividing by negative, which would mean you'd have to turn the sign around. Since we don't know what the variable is, we don't know if we need to turn the sign around. So, when you solve this, you basically find how to divide the number line up into the sections, and in those sections, the statement will be either true or false, and then you check them within each section. Don't rely on this. This doesn't actually tell you what the answer should be. So, because you can't rely on this inequality, we basically cancel it out, and we come back to it later. So instead, we get everything on the same side and we say, well, let's call this an equation. 1 over 2t plus 3 over 4t equals 1. And then let's get everything on the same side. 1 over 2t plus 3 over 4t minus 1 equals 0. If we can solve this, we'll have those possible values for t. So you rewrite it as the related function. Multiply it by the least common denominator. That'll be 4t, since that contains both 4t and 2t. Multiply everything by 4t. Here the t cancels out, and you get 2 times 1 Here 4 and t cancel out, and you've just got 3. And then here nothing cancels out. So this is 2 plus 3 minus 4t, so 5 minus 4t. And over here we've got 4t times 0, which is just 0. T equals 1.25. Exclusions, because you always have to check for exclusions, what values of t would cause you to divide by 0? Well, t being 0. If t was 0, this would be 0, and this would be 0. So we've covered our exclusions. You make a number line. You mark all your exclusions, and then all your solutions, and then figure out your regions and where it's true. So we know that the value cannot be 0 because it would cause division by 0. We know that one of the boundary lines is going to be at 5/4 or 1.25. Since this is a strictly greater than, we know that it's not going to be true at this boundary. So that's why it's an open circle. Then you check where it is true. There's a couple of different ways of doing this. You can just pick some random number in this area. So -1 and plug it in is 1 over 2 times -1 plus 3 over 4 times -1 greater than 1. Let's see, this is 1 over -2 plus 3 over -4. Is it greater than 1? No. Then it's false in this area. And then you can pick something in here like 1, check it, it turns out to be true in between, and pick something over here and check it, and it turns out to be false over here. But I'm going to give you a shortcut. You have to do the math, both because I want you to do the math, it's good for your brain, and because it is necessary to figure out exactly where these lines are, and the calculator won't necessarily be able to tell you that. So you've got to do the math to figure out where the lines are. But to check for which regions it's true, here's what you can do. You got to be careful with your parentheses, but you can do it. So we are going to plug the inequality into the calculator, and it's going to tell us 0 for false, that is 0 is false, and 1 for true. So 1 over parentheses 2x, you've got to use x, and of course if you want it to be on the bottom, you've got to put it in parentheses, plus 3 over parentheses 4x, go into your test menu, say greater than 1. And it will go through all the x values and check them to see if this is true or false. So, oh, sorry, my graph is still strange. Set to a different window. Let's interrupt that. Here we go, back to a standard window. Okay, this is a 0, so it's false everywhere less than 0. Then it becomes true for this little area, and then false again. And that little area is the area in between our boundary lines, 0 and 1.25. So the answer is t must be greater than 0 and less than 1.25. Or you could, if you want, you could say t is greater than 0 and t is less than 1.25. It's the same thing. I know it's a little cumbersome, but that's the best way to do it. To solve this, we multiply by the least common denominator. What's the least common denominator? Well, we got 24. 4 is already a factor of 24. And 3 minus x. You may notice 3 is a factor of 24, but I can't split this expression up. If you have an expression that's basically a polynomial by itself, you can't split it up and say, oh, well, the 3 is a factor. You could only look at this being part of it if 3 minus x was a factor, the whole thing. So this is our least common denominator, 24 times 3 minus x. So here's what I'm going to do, and I'm going to write everything out. I know this takes a while, but it really helps you to keep from making mistakes. I'm going to multiply by 24 times 3 minus x, 24 times 3 minus x, and run out of ink apparently, 24 times 3 minus x, each one of my terms. And then I can cross to show canceling. So I cross off the 24 on top and bottom, hoping for another pen, but I guess not. So here I've got 5 times 3 minus x, so that's 15 minus 5x, plus, here the 3 minus x cancels out, and I've got 24 times 2, or 48. And here, 24 over 4 reduces to 6. I've got 6 times 3 minus x, or 18 minus 6x. Sorry about that. I don't have any squared terms, so this is going to be a simple linear equation. I'll go ahead and add 6x to both sides, and also combine my like terms. So negative 5x plus 6x is x, 15 plus 48 is 60, oops, sorry, I'm still on the same side, is 63. Subtract 63, x equals 18 minus 63, which is negative 45. Double check my exclusions. What value of x would give us a denominator of 0? Only x equals 3. Negative 45 is not 3, so that's fine. And of course, you should always check your work. So 2 over 3 minus negative 45. Is that the same as 1/4? Yes, it is. So we got it right. So, multiply by the least common denominator. Simplify and solve. Check your exclusions. And check your solution. Sometimes to multiply by the least common denominator, you're going to have to factor. This factors into x plus 4 times x minus 1, which turns out to be the exact same as these. So multiplying by the least common denominator, the x plus 4 cancels out, and I've got x squared minus x minus the x minus 1 cancels out, and I've got 2x plus 8. Please be very careful. This minus is going to have to get distributed here, so don't forget those parentheses. And here, top and bottom will both cancel out, and we've just got 20. This x squared minus x minus 2x minus 8 equals 20. X squared minus 3x minus 28 equals 0. This factors into x minus 7 and x plus 4. Set each factor equal to 0. X equals 7, or x equals negative 4. Check your exclusions. X cannot be negative 4. X cannot be positive 1. So that means this solution does not work. So our only solution is x plus 7, and you should of course put it in your calculator, but I'm not going to in the interest of time. Very simple one, just multiply by the least common denominator, which in this case is a. You're going to get a squared plus 5, or sorry, minus 5 equals 4a. Don't forget, please, everything gets multiplied by the a. A squared minus 4a minus 5 equals 0, because it's quadratic, so we want everything on the same side. This is a minus 5a plus 1. A equals 5, or a equals negative 1. A cannot be equal to 0, so these are both good, and you would plug them both in. 5 minus 5 over 5 is 4, yep. Negative 1 minus 5 over negative 1, that is negative 1 plus 5 equals 4, yep, all good. Here, now the same thing applies. You would multiply by the least common denominator. You can also cross multiply. That's doing exactly the same thing. You multiply this by b plus 5 times b minus 3, and what happens is that those cancel out. And over here, same thing. These cancel out. So it's the same effect as cross multiplying. 9b minus 27 equals 3b plus 15. 6b equals 42. b equals 7. Check your exclusions. B cannot be negative 5 or positive 3. That's okay. Factor. This is t times t minus 4. Multiply everything by t times t minus 4. Here the t cancels out, and you'll have t plus 4 times t minus 4. Here the t minus 4 cancels out, and you've got 3t. And over here, both of them cancel out, and this is just negative 16. This is t squared minus 4t plus 4t minus 16 plus 3t equals negative 16. T squared plus 3t, adding 16 to both sides gives you 0, equals 0. T times t plus 3 equals 0. T is 0 or negative 3. T cannot be 0 or 4, so that rules this out, and that's our only solution. Remember to rewrite this as the matching function. So I'm going to subtract 16x. That'll turn this into 5 minus 15 over x. Equals 0. Multiply everything by x. We get 5x minus 15 equals 0x. 5x equals 15. X equals 3. Our exclusion is that x cannot be 0. And this is an inequality, so this is one of those ones where we mark it again. Everywhere less than 0, this is either true or false. That is, it is either true everywhere less than 0, or it is false everywhere less than 0. You're not going to get a mixture. That's what those boundaries are for. So now, 5 plus 1 over x is, now we can put the inequality back in, greater than 16 over x. I only need to see between 0 and 3. So it's true less than 0, false between 0 and 3, and then true again above 3. So x is less than 0 or greater than 3. When this is an exclusion, it's always going to be an open circle, so it's strictly less than. It can't be that, or you'll be divided by 0. This one depends on what the original was. This was a strictly greater than, so this is a strictly greater than. It would still be an open circle. Change it into the corresponding, function. 1 minus 7/6 is negative 1/6 plus 5 over a minus 1 equals 0. Multiply by your least common denominator here, which is here 6 times a minus 1. 6 will cancel out. This will turn into negative a minus 1. Remember your parentheses. Plus, here the a minus 1s will cancel out, and we'll have 6 times 5, which is 30. And here 0 times anything is still 0. So, negative a plus 1 plus 30 equals 0. 31 equals a. And our exclusion is a cannot be equal to 1. So clearly our graph is going to have to be a little bigger. That's why I had that big one to start out with. 1 plus 5 over, please don't forget these parentheses, x minus 1. Test is less than or equal to 7 over 6. I'm going to make sure my window goes from negative 10 to 50. You can certainly look at the table. There's nothing wrong with that, but I didn't mean to. Since we already know where they change values, we only need to have a sort of rough idea here. Everywhere less than 0, it's less than 1, it's true. It's false between 1 and 31, and then for values greater than 31, it's true. This was our exclusion, so that's always an open circle. This is an or equal to, so that'll actually be a closed circle. So a is less than 1 or greater than or equal to 31.